Hello everybody, welcome to another video lesson. We are going to be looking at population parameters today. At the end of this video, we will be able to use our sample data to estimate population means and proportions, and then we're also going to take a look at what a margin of error is. So hopping into our population parameters, this is a term that we've seen before. Remember, this is a number that represents the entire population. P for population, P for parameters. Now, our population mean is a very specific type of population parameter. A population mean is just the calculated mean or average of the entire population, and we denote it with this Greek symbol mu. Okay, that's how we say it, mu. Right, mu is how it's spelled. It looks like this, and we pronounce it mu. Right, kind of like U with an M at the end or at the beginning. Okay, and also we have population proportions. That is the number of members of a population sharing a characteristic divided by the number of members of the entire population. So it's very similar to our sample proportions that we looked at in a previous video, and we're just going to denote that with a lowercase p. So a quick example here, we have some test scores from 5 students. Our population mean is going to be represented by this here equation, all right? Mu is equal to the sum, okay, remember our sigma notation looks like this, the sum of x of I. So this is going to be all of the terms of whatever we're looking at added together, divided by the total number. So in this example, if we're looking at the total sum of test scores, okay, that's what this sigma notation would denote, the total sum of test scores divided by the total number of test scores. So here we have 100 plus 94 plus 91 plus 74, plus 78 plus 75. That's going to be the sum of our test scores divided by the total number of test scores that we have, which is going to be 5. Okay, that's how we calculate the population mean. Now our population proportion, now I need to think of what particular trait I am going to be referring to or really evaluating when I look at this population proportion. So in this case, if we were to look at the number of test scores above 90, well, I've got 1, 2, and 3. So that would be 3 divided by the total number of tests, which was 5. Okay, so our proportion here, population proportion, would be 3 over 5. Let's take a look at what margin of error looks like. That is the interval in which the result will fall relative to the real population value. Now, I know that's kind of a difficult definition, but really all our margin of error is something that's going to help us determine how reliable our study is. Now, previously we've talked about study reliability from the random sampling standpoint and from trying to reduce bias, right? This is not so much referring to that as it is referring to the size of my sample, okay? The size of my sample, and statisticians have found that the larger the sample size, the smaller the margin of error. Okay, so the smaller our margin of error, the more reliable our study is going to be. And we calculate our margin of error with this here equation, plus or minus 1 over the square root of n times 100, where n is going to be our sample size. So you can see that the larger n is here, then the smaller this value will be, so the smaller our margin of error will be. All right, let's go ahead and get into some examples. So what is the population mean for the number of hours worked per day? If we have this data here of number of employees in a company and the number of hours that they work per day, and we see that's in between 3 and 5. So here we have our equation for finding our population mean. Now, keep in mind that what we have here in my numerator, it's going to be the sum of x sub I values. So each x sub I term is going to represent the number of hours worked, okay, that's my x, by the employee I. So I is kind of like my counter, right? So employees 1 through 4, since there are 4 employees in this 3 hours bracket, employees 1 through 4, that would be like 3 plus 3 plus 3 plus 3. That would be x sub 1 time, plus x sub 2 plus x sub 3 plus x sub 4. And those first 4 employees worked 3 hours per day. So that's going to look like 3 times 4. And then we're going to add now, since we're just going to keep going, 4 times 12. And then we're going to add 5 times 21. Again, just using that same logic that we used in this first category. divided by my n, so the total number of my population. So in this case, that's going to be 4 plus 12 plus 21, all of the employees within this company. So I'll get 165 divided by 37, which is approximately 4.459, and some more decimals here. So our population mean is going to be approximately 4.46 hours. All right, taking a look at population proportion. So we have a population of 250 people. We have two different scenarios here. We're going to calculate the population proportion for each scenario. So 105 people prefer running over hiking. Okay, so my P is equal to the attribute that we're looking at. So the attribute that we're looking at is preferring running over hiking. Okay, that's the attribute that we are trying to find the population proportion of. Divided by n, where n again is my whole population size. In this case, that's going to be 250 people. So that's going to be the proportion 105 divided by 250, which gives me a proportion of 0.42. All right, similar for this second situation, I've got 55 people that prefer hiking over running. So this is now the attribute that we're looking at. This is a separate situation here. So we've got 55 people that prefer hiking over running divided by my total population size of 250, which gives me a population proportion of 0.22. All right, a survey is conducted to determine the most liked color of the rainbow. The results of 200 people, okay, we're going to need to know that, surveyed show that 44% of the people like blue the most. Find the margin of error. So we have our margin of error equation here, where n is my sample size, and we know that that is going to be 200 people, because that is how many people were surveyed. So I'm just going to plug in 200 into n here. So I've got 1 divided by square root of 200 times 100. And 1 divided by the square root of 200 is about 0.0707 and some more decimals. Times that by 100. And again, remember I said we're calculating a percentage with this margin of error. So it's going to be about plus or minus 7.1%. Now, what does that actually mean in the context of this problem here? Well, that means that I have 44% of people that like blue the most in this study. However, worldwide, if I were to ask everybody on Earth what color of the rainbow they like the most, you're not going to get 44% of people that say they like blue the most. You're going to get them, it's going to be within some range from this 44%. And how we find that range based off of this study is I would take my 44% and I'm going to subtract 7.1%. That's going to be the lower end of my range. And then I'm going to add 7.1%, and that's going to be the higher end of my range. So the real proportion of people who like blue the most, okay, the real proportion accounting for my margin of error, is going to be between 36.9% and 51.5%. So that's how we can use our margin of error to really look at the real proportion from our study compared to if I were to apply this to like a worldwide thing, okay, or my larger population just in general. All right, last example here, looking at margin of error, we have a study or a survey that we want to conduct, and we want a margin of error of plus or minus 4%. Now, 4% is pretty low, so really anything in between 4 and 8% is considered a pretty good margin of error. So if we want a margin of error of plus or minus 4%, we need to find the necessary sample size for our survey. So all we need to do is we have our margin of error equation, and I'm going to set that equal to this plus or minus 4%. Now we got plus or minus on both sides, so let's ignore those for now. And then let's multiply both sides because we need to solve for n, right? N is our sample size, that's what we're solving for. So we're going to multiply both sides by the square root of n over 100. And you'll see that my hundreds cancel out and my square roots of n cancel out on this side. So I'm left with 1 on this side. And then 4% divided by 100, that's going to be 0.04 times the square root of n is equal to 1. Now I can divide both sides by 0.04. These cancel out here. And I'm left with the square root of n is equal to 25. I square both sides of my equation. And I find that my sample size needs to be 625. So that's it for this video, guys. Good luck with your practice.